Okay, in this lecture we're going to talk about graphing inverse functions. Now I've already talked about how to find an inverse function. The first thing is, of course, is that the function must be one-to-one. So let's look at an easy example here. Let's suppose here's our function 2x plus 1. This is one-to-one because it's a linear function, and we can show it's one-to-one because we can see that if f of a is equal to f of b, then we have 2a plus 1 equals 2b plus 1, which means that 2a equals 2b, which of course means a equals b. So it's certainly one-to-one. We know that it's a linear function. It has a domain of all real numbers, and we know that it has a range of all real numbers. We know this is a linear function with a slope of 2 and a y-intercept of 1. We can actually plot some points, okay, and as we've seen here, we can plot some points, right? When x is equal to -2, right, we have y is equal to -3. Right, when we have x is equal to -1, we have y is equal to -1. And when x is equal to 0, we get 1. When x is equal to 1, we get 3. And when x is equal to 2, we get 5. Right, so we know how to draw this function. Now it's one-to-one, so there is an inverse. Alright, so there is an inverse function. And how did we find it? Well, we had a number of steps. Step 1 was we write the function as y equals 2x plus 1. Number 2, we interchange x and y, so what we get is x equals 2y plus 1. And now 3, solve for y. So we end up with 2y equals x take 1, and y therefore is equal to x take 1 over 2. And step 4, we call that f inverse of x equals x take 1 over 2. And that's what g is here, is our inverse function. Right, now our inverse function then, if we look at this one, alright, and if we put in values of x, for example, -3, we get -2. If I put -1 in here, I get -1. If I put 1 in here, I get 0. If I put 3 in here, I get 1. If I put 5 in here, I get 2. So we end up with this table, alright? And this is actually a line, of course, which is a slope of 1/2 and a y-intercept of -1/2, and that's this red one here. Now you should notice something else that's important about this. Here's our ordered pairs, -2, -3. Down here we have -3, -2. Here we have -1, -1. Here we have -1, -1. So that's this point here. Now you'll notice that if I draw a line y equals x, alright, then these points are exact mirror images of each other across the line y equals x. And if it's actually on the line, then it just stays as the same point. So you'll see here that in actual fact, an inverse function is just the reverse of the coordinates. And that leads us to be able to graph these rather well. And it also leads us to understanding what we mean by the range and the domain. In this case, again, the range is this. And that's going to become very important, because if the x's, alright, become the y's in the inverse function, okay, here they are here, and if the y's in this function here become the x's in this function, right, then we have a relationship between the range and the domain. Alright, so in other words, the domain of f is equal to the range of the inverse function, and the range of f is equal to the domain of the inverse function. Okay, so we have this relationship, and this all comes from this particular point here where we interchange the x and y, because we want to try and put this on the same rectangular coordinate system with the x-axis here and the y-axis here. Okay, now so the way we graph them is then to first of all graph the function that we have, put a line y equals x through there, and then just reflect the points across. In other words, reverse the x and y's and draw the function. Alright, so that's going to be our mode of operation. Now you'll notice that we had some differences here with some functions. Notice that this was the one we just did and this was 1 to 1. But if I look at this one here, this is not 1 to 1. Why? Because the horizontal doesn't satisfy the horizontal line test. Okay, so this one fails the horizontal line test. So it is not 1 to 1. And this one, alright, satisfies the horizontal line test. Alright, so what are we going to do here? Because we know this is the squaring function, and you would think that the reverse process, alright, so the reverse should be square root. But since it's not a one-to-one function, then we can't find an inverse. So what we do is we restrict the domain. So if you look at the next picture here, you'll see that what we do is we restrict the domain. So let's suppose that we draw f of x is equal to the squaring function, but we limit the domain here, all right, to x greater than or equal to 0, so it's from 0 to infinity. Okay, now notice that that just gives us this positive side. Now this is 1 to 1. Okay, so it's 1 to 1, so there is an inverse. Right, and of course here's the domain. Well, what's the range? Alright, well the range of this function, right, is going up from 0, of course, including 0 to infinity. Okay? Right, so the way we graph it then is we put our line y equals x in here. Alright, we know that it goes through the point 1, 1. Okay? We know that we have it here at 0, 0. Now it also goes through 2, 4. So when I draw the inverse, it still goes through 1, 1 and of course 0, 0, but now of course it goes through, instead of 2, 4, it should be 4, 2. And of course we know how to find what the inverse is. Of course it's the square root is the reverse process. Alright, and you'll notice here that of course step 1 is we write it as y is equal to x squared. Number 2, interchange x and y, so we end up with y squared equals x, and then step 3, solve for y. Now notice here that this must be, remember, because of our domain we can only get a positive result here, so we end up with y is equal to the positive square root of x. And step 4, we call that our inverse. And of course, what is the domain? Well, the domain of the inverse, of course, is the range of the function. And the range of the inverse, of course, is the domain, all right, of the function, like so. And so here is our picture. Okay, now if we put that together, alright, notice that what happens when we put this together, here's our two functions. Here's f of x equals x squared, having a domain greater than or equal to 0, range greater than or equal to 0. Here's our line y equals x, and we reflect it. Notice the point here that's common to both of them is 1, 1. And our g of x, which is our inverse function, is the square root of x. Again, the domain is greater than or equal to 0 and the range is greater than or equal to 0. Right, and so that's our inverse, how we graph inverse functions. Now let's look at this next example. And you'll see here that we have a function, right, that f of x is equal to x minus 2 squared, but of course its domain here is x is greater than or equal to 2. So that makes it the parabola, which has been moved 2 units to the right, okay, and it's only the positive part of it, so it's this part of the curve here, and so it is 1 to 1, okay. Now if we want to find the inverse, of course, then we write it as y equals x minus 2 squared, second one, interchange x and y. So I end up with x equals y minus 2 squared. Now we take the positive square root, so y minus 2 is going to be equal to the positive square root, alright? And of course here we have y is going to be equal to the square root of x plus 2. Alright, so notice that that's the square root function lifted up 2. Now, if you look at this, when x is equal to 2, in this function we end up with the point 2, 0. So, if we're interchanging x and y, we're going to end up with the point over here of 0, 2. Okay, here's our line y equals x. Okay, alright, now when we go to 1, for example, when x is equal to 1, we're going to have minus 1 squared, which is 1, so that also is here. And of course, in this case here, when x is equal to 1, right, we're going to, sorry, when we do that one here, we can't have 1, of course, because x is greater than or equal to 2. So, just reviewing that, let's look at 3, for example. When x equals 3, of course, it's 1, so that's what we should be doing. So that's right here. Okay, so this point here will be 3, 1. So 1, 3 should be our point over here. Okay. Alright, so here's our line y equals x, right through here. Okay, notice that if I go to 4, okay, if I put x as 4 in here, I get 2 squared is 4. So that would be 4. And this point here is 4, 4, which of course is on the line y equals x, and so it just stays there. So in other words, we have our parabola that comes up here, through here, and then we have our square root function, alright, square root of x plus 2 coming through here like this. And so you notice here that we have exactly a nice mirror image across the line y equals x. And of course we'd call this one the inverse function, plus 2. Right, so this is the x minus 2 squared function, alright, which moves, notice, 2 units to the right, and it's just the regular squaring function then. This is the square root function. The regular square root function is down here, but we've lifted it up to, right, in the vertical direction. This one's horizontal, this one's vertical, alright, to get our picture of our 2 inverse functions. Now notice this carefully, that the domain of this function here is greater than or equal to 2, which will be the range of the inverse function. Right, the range of the function will in fact be the domain of the inverse function. So don't ever forget that kind of relationship.